for technical issues. So today we have Orfeas from Technical University of Athens, and he's going to present us today about explainability and to contextualize bias in human and machine language. The floor is yours. Let's start.
Thank you very much. Thank you very much. So hello everyone, I am Orfeas Mastromichalakis from the National Technical University of Athens. And today I will present basically two lines of work that we had along with some colleagues on biases. The title is Words We Inherit, Words We Generate, and about uncovering and contextualizing bias in human and machine language. Sorry, I don't have control. Yes. So let's basically start from something that I don't have control. Oh, sorry for that. Oh, yeah, okay. So let's start basically by a very brief introduction of what bias is, at least in this presentation. The aspect ratio is not good, right? Okay, no worries. So when we refer to bias, at least for us here, we refer to a systematic inclination or prejudice that affects judgment, representation, or behavior in ways that may lead to unfairness, distortion, or exclusion. This is not a very typical definition of bias. It's just a definition of bias that I did while talking with ChatGPT. But something should appear now. And it's just to include the two forms of bias that we will address in this discussion. That should be, yeah. One line is about biased language, when we refer to the use of words or expressions, generally terms, that carry derogatory, exclusionary, or stereotypical connotations towards certain groups, perpetuating harm and reinforcing social inequalities. And the second direction, let's say, of bias, sorry, my clicker is not working. Yes, maybe I'll just need to click. I will sit and click on it. And the second is about algorithmic bias, about systematic patterns within AI outputs that reflect or amplify societal stereotypes, resulting in unfair or unbalanced treatment of different genders, ethnicities, etc., other social groups. So we have two main directions: biased language and bias of algorithms. A brief presentation outline is a brief introduction and this outline. Then we move to the first line of work, which is about the words we inherit. So about detecting and contextualizing harmful language in cultural heritage collections. For those not familiar with cultural heritage collections, we refer usually to records or data from museums, cultural institutions, or any form like that. Then we move to the quantifying gender bias in machine translation, and it's a study about gender ambiguous occupational terms. Then just a list of some relative publications from our team and some conclusions and next steps. So first, about words we inherit. This whole work started when we were working with some cultural heritage professionals in some projects, and they had the concern that the metadata of those collections often contains outdated or offensive language. We have some descriptions, some titles, let's say, of some cultural heritage objects that they reflect, let's say, historical cultural norms, power structures, and other biases that at that point when they were written, they might seem appropriate, but they no longer are. And they are still there in the collections, and they create many problems in terms of searchability, in terms of inclusion, etc. But their concern is not that they could just remove these terms, because they were part of the actual cultural heritage item. You cannot simply erase that. This is like hiding the problem, let's say. So you obscure historical realities and silence, let's say, critical perspectives on past injustices. So with our work, we aim to detect harmful language in CH metadata and provide some contextual explanations and some suggested alternatives of these terms in order to create, let's say, more inclusive collections in the CH domain. Didn't do it? Okay. So yes, TLDR, we just need to detect harmful language, inform people about it, and not completely remove it. Some few questions. I tried to include some examples that are not that offensive, so I think that no one has a problem with that. Sorry if it's a problem with anyone. And we have some examples with some terms. Here we have, let's say, the invalid. The term invalid was used to be used for people with disability. But as you can understand, the term, let's say, implies that the person is less than their contemporaries. So it's no longer appropriate to use. We have many other examples, let's say with Oriental, which basically groups all Asian identities. Okay. And we have also many other examples. I don't want to get into more details. I didn't even touch on this. But you can understand basically the whole concept that there are some terms that are offensive. And this is also a problem from people from these communities. When they access these platforms, it's not, let's say, the best experience when you see, let's say, colonial terms, or you see terms that are offensive against your community. So as we said, we cannot simply remove these terms. Yes. Yes. Oh, no. Yes, I screwed the screws in order to make it more stable, but I don't know. Okay. So, okay, proceeding as for the time that we have image. So yes, we cannot simply remove these terms. We need to inform people about it. And it's not, as I said, about censorship. It's about transparency and inclusion. It's something that we have discussed a lot with such affected communities. And in this task, general purpose tools like other maybe toxicity filters that you may have seen, some works that work on social media filtering, etc., they don't particularly work because in some cases the terms are not so useful, so frequently used in such contexts, so you cannot really find them in most of these cases. And also, if you in these approaches, you don't usually have a grounded explanation or just a definition of what exactly this term is, where it comes from. So we want to have a grounded, let's say, information that we provide. And another issue that is often ignored is how this affects searchability. So imagine that I'm searching for some records about disability, and the records are just have descriptions about invalids. So in that case, you need to not remove, but maybe enrich the metadata with some terms or some tags that can help also searchability. And that's where we also provide some suggested alternatives that can be used to improve the metadata to also assist in other tasks. So our approach to this problem is we create a curated multilingual vocabulary of half-form terms. Our approach is term-based. This might seem a bit old-fashioned to some people here, and I know it is, but we wanted to have a very specific reference. And for that, we needed to have specific descriptions of the terms that we consider derogatory or harmful. Then we built a tool to use that vocabulary to detect and contextualize, let's say, terms. And the whole purpose of this work was to create a real application, and actually an application that can be used in large-scale deployments. And so we provided also a standalone service, and we integrated the tool with some big platforms, basically Europeana. Europeana is the EU platform, let's say, about digital heritage. It has millions of users per year. It incorporates data from various museums, institutions, anything. And this was a major partner of this work. So this led to a vocabulary in 5 languages: English, German, French, Italian, and Dutch. We would like to expand it to more, but budget is an issue. We have almost 700 terms. I think the last time I checked, it was 687. Some major topics include migration, colonial history, gender, sexual identity, etc. And what is important about this is the way that this vocabulary was created. We started from some existing vocabularies and some lexicons, etc. And we had a team that their task was to curate such a vocabulary. So they collected terms, they created some draft descriptions about these terms based on some already academic research. And then we took what we had created and we went and had some workshops along with some community partners. So we had, let's say, some workshops about sexual identity, about gender, with feminist groups, with LGBTQI members, etc., about colonial terms, with some people involved in this domain. So we went and we asked them to reflect on what we had prepared and enhance it. I think around 60 people contributed to this part of the creation and refinement of the vocabulary. Well, the vocabulary follows the SCO standard, and it is already published in EU Vocabularies, a repository by the Publications Office of the EU, where you can find open source vocabularies. A couple of examples of what the structure might be. As you can see also in the graph below, we have the term itself, the contentious issue, which is basically the description, what is wrong, let's say, with this term. We have a suggested term, suggested alternative, suggestion note on how to handle when you find this term, and we have a category. This is a simplified version. We have also some more information about attribution, sources, many more, but this is the crucial information, along with a flag that we will see later. So now we have our vocabulary. We're ready to get, let's say, an input text, find the terms in the text, and we're done, right? Almost. Let's say that we have an example. We have invalid in our vocabulary, not invalids, but okay, I can use a lemmatizer or something, and we get gender variations, plural, etc. That should work now. So yeah, we detect. And we proceed. Okay, we have other, we can have, variations like gypsy with a Y or an I, and it works until you see that some might be, let's say, part of a named entity. Okay, there's the Gypsy Kings, the band. We don't really want to flag the term there. So let's say then we use a named entity recognition and we filter out those that are part of named entities. In the data that we used, we saw that in many cases, some of the terms were actually part of surnames for some reason, because we also had some general terms that is not offensive in all contexts, but that named entity module, let's say, filtered out many false positives. So now that should be okay, right? The graph seems complete, so I think that might be okay. But yeah, we have some terms that, of course, as you can imagine, they are derogatory depending on the context. We have many terms, so if you just let the system without any other contextualization of the detection, it would flood with false positives, and it wouldn't be useful. You can't use a detection system, an alert system, let's say, that alerts you all the time. It will ruin user trust, and no one will use it. So for that reason, we saw that some terms of our vocabulary were always derogatory. They're always offensive. We have the N-word. We have many things. But other terms depend on the context. And in fact, these terms usually are not derogatory. So we added the flag that I mentioned earlier for these terms that they need, let's say, a disambiguation step. And for that, it's not just the invalid that we say. There were many other terms and in multiple languages. So for that, we added an LLM component that basically takes the detection, takes the input text, the description for our vocabulary, the suggestion from our vocabulary, and decides whether the term is indeed used in a derogatory context or not. And that actually worked pretty good, and also with some smaller LLMs. We will see later what we used. And one last step is that for some languages, for example, in German and Dutch, we saw that you can create derogatory terms, like offensive terms, by just taking an offensive term and concatenate it with something else. It's just something that you can usually do in German. You can just create words by just concatenating words. So we also created a compound word splitter for these languages, as this was an issue identified by some colleagues from which were native speakers and were going through the example data that we had. A question that makes sense here is why use the NER module, since you already have an LLM, if that could also be filtered from the LLM. Yes, of course it could. But as we said, we cared about efficiency a lot because we use this tool to annotate. Until now, I think it's almost 8 million records. So efficiency is a big point, and also cost. And so we wanted to use the LLM as less as possible. So we saw that the named entity recognition module, first of all, worked a little bit better compared to you putting everything in the LLM, and improved the efficiency a lot. And also, this also answers the question of why using the LLM only on flag terms and not on all terms. Since we know that some terms are always derogatory, there's no meaning into putting it into the LLM and just hope that it will do its work. So more or less, this is just a vocabulary-based fuzzy string matching with an LLM for disambiguation, just on steroids, let's say, in some case. So we, as I said, we tried many different LLMs. We had some limitations, so we used only small ones or a bit larger ones with some quantization. We started with European-based LLMs in most cases, and we just added Llama since it was a widely used one. As you can see, the results do not differ much because the task is rather simple in some cases. To evaluate the precision, we created an annotated data set of 3,700 texts, which we basically, it spans across all our vocabulary terms, and we created it through crowdsourcing campaigns. So we collect some data, we run our tool on this data, and then we put the detections for some users, here like 140, 45 people, to basically approve or reject the detections of our tool. For that reason, we could only calculate precision accurately, because recall requires that you may still have some random text annotated to see if the tool missed some things, but derogatory texts are very sparse in cultural heritage metadata. So in that case, we tried to collect, let's say, a collection of 200 or 300 texts. We had no detections, so it would be too time-consuming and too costly to annotate random text. So for that, that's why we only report precision in this work. And the other table here, table 1, shows what I mentioned earlier about the effect of the LLM and the NER module on efficiency, the throughput. This is, I think, characters per second. I'm not sure. So you can see that using only the NER module improves the throughput greatly compared to using an LLM. And that's why we want to avoid using the LLM as much as possible. So as I said, for the application of this work, we integrated with some major cultural heritage platforms, Europeana and Mint. As I said, Europeana is a platform accessible to anyone about digital cultural heritage. Mint is just, let's say, a tool that cultural heritage institutions use to publish their data to Europeana or other repositories. For that, the colleagues from Europeana also created a UI module where you can use, when there is a term, let's say, detected by our tool, there is an icon of our project where you can hover and have, let's say, the explanation. When you click, it takes you to the vocabulary entry. You have more information, linked vocabularies, and everything. And that's also something that we had in mind when preparing the descriptions, because according to some UI instructions, we had to keep it as concise as possible because they wanted it to be displayed in a way that it can inform users. You just can't just flag it and then make the other one click, go to other pages. This was part of the design of the vocabulary as well. We provide also a standalone tool and an open API for everyone to use, because that was a request by many CH institutions, as their budget and their technical, let's say, depth is not much. So we decided to make it open for anyone to use, not only open source the tool, but also deploy it in our servers so that anyone can access it without the need of deploying it. The standalone tool, it's the link shown down here. It's just a very simple UI. You can decide choose the language, decide to activate or deactivate the name identity and the LLM to see the effect. And then you can add as many texts and you get the results in a form like that. You can download and everything. And as I said, we have already processed almost 8 million records across all 5 languages. And we have updated their metadata so that they can be displayed. This is in collaboration with Europeana. All these records are done in the Europeana platform. And closing with this part, it's just a few challenges. As you can imagine, multilinguality was a great challenge, especially when the developing team was basically only Greeks and none of the languages were Greek. So we had a big issue on evaluating, let's say, the first results of our tool. We needed to always keep in the loop some colleagues that were native speakers. As you can imagine, many of the tools, the libraries and the LLMs do not perform equally across all languages. So we all had also this issue. We were considering about using different LLMs depending on the language. In the end, we chose that Llama was a good, let's say, middle solution for that. And about the LLMs, especially for smaller ones, it was a bit hard to make them have a specific, let's say, format in the output. There are ways to limit it, but it was a bit challenging. And also in the fact that because we wanted efficiency, we limited the output tokens, which made the LLMs, let's say, answer with yes or no. Is it offensive in this context or not? But as you can imagine, you know, if you have a binary, even if the reasoning behind it is a hallucination or something wrong, you can still have some good results. So we're still discussing about doing some work on allowing some context to be outputted so that we can evaluate also the reasoning behind the decision. It seems accurate, it seems precise, but we also need to see that the rationale is correct and it's not that by chance, let's say in some cases, it's correct. And yes, okay, on the last one, I will not stick too much. It's, as I said, that now we only take text as input. It might be useful to have also other fields. So if you take the description of an item, the creator is very important in some cases. Maybe the date, because you can see when the item was created. Also, in many cases, you cannot deduce if it is offensive or not by just the text. If you see, let's say, an ape dancing, which was the description, if indeed it's an ape, it's okay to use. But if it refers to black person in colonial Africa, of course it's not. So a next step that we would like to make is to also incorporate some VL models that we can also process the images of the data. And okay, the vocabulary creation had many challenges. I will not get into that. And then we can proceed to the next part, which is about the bias of the models. Here we shift to machine translation, and we will discuss about quantifying gender bias in machine translation. And we focus on a specific part, which is gender ambiguous occupational terms. This is, I think, one of my favorite works of the last year. So we all know that machine translation is a big part of our everyday life, from social media, meetings, everywhere. We use empty systems, even if we don't explicitly do. And they frequently exhibit gender biases that reinforce societal stereotypes. We focus on the labor market, where, of course, we know that gender disparities persist, and such biases are especially problematic as they extend beyond language. We know that they can subtly validate or reinforce occupational segregation by shaping perception of gender roles. And this affects, let's say, hiring practices, career aspiration, wage disparities, etc. This is all reflected on also in the European Commission's gender equality strategy. And we, let's say, classify unofficially into two forms of how gender bias can manifest in such systems. One is explicit biases, let's say misgendering. If you have, let's say, to translate that he went to the hospital because he works there as a nurse. Some translation systems, especially some years ago, now they have fixed it mostly, may translate the nurse in feminine form when translating, let's say, into Spanish or Greek, that you have grammatical gender. But that's a clear error. Let's say you can have a reference translation. You can see that it is a wrong and mistaken translation. And that's much easier to evaluate. But there's also another form that we tackle in this work that is, we call it now here subtle biases, but it's about when you have some ambiguous inputs. Let's say the doctor arrived. In English, you have no gender indication, but when you need to translate to a language with grammatical gender, you may need to make, let's say, an assumption and assign a gender to that. While a single translation is not wrong or biased, yeah, if you translate the doctor into a masculine form or a feminine form, they're equally correct. But the problem is that if you consistently translate the doctor into masculine forms and the nurse, let's say, into feminine forms, that we all know that empty systems do, that's where you can see that the system may have a gender bias. Yes, I think, yeah. And the important is that traditional, let's say, bias evaluation approaches that take as granted that you have a reference translation, as I said, cannot work in this. So in this work, we focus on translations from notional gender language, English, but that could also work from genderless languages, like I think Hungarian, Finnish, Turkish, etc. When translating into a language with grammatical gender. Here we use Greek and French, but other languages are Spanish, Italian, Portuguese, etc. So the issue is that these systems, as I said, have to assign a gender, they have to have an asterisk. We'll see later that there are some alternatives, but they're not frequently used by empty systems. And while individual translations may not appear biased, systematic patterns like the consistent assignment of certain gender into specific occupations can emerge, which shows the problem. Yes, so TLDR, empty systems must assign gender when translating ambiguous inputs into gendered languages. This creates a challenge for evaluation, as systematic bias can emerge despite the absence of a single correct translation. And the last part is important because that's what differentiates us from other evaluation frameworks. But let's see this must assign a gender part of how can an empty system handle, let's say, gender ambiguity when translating. One idea which is sometimes possible is to preserve the ambiguity. In some cases, it's also possible to use gender interphrasing, avoid some pronouns, etc., when translating to grammatical gendered languages. But due to grammatical constraints, let's say in many languages we have suffixes that indicate gender, as I said, pronouns, etc. That makes it infeasible. So a very few examples we're able to preserve ambiguity in some experiments that we did. A related but not exactly the same approach would be to use gender neutral language. So it means to use inclusive forms. Let's say it's the same as using they, them in English, that you don't want to express gender. This is something that is getting attention. There are some works that that address this, the translation into gender neutral forms. But as far as I know, there's no widely accepted or standardized forms in many languages of how this gender neutral form should be. And it's also sometimes seen as ungrammatical, say, awkward by native speakers. But that doesn't make this line of work less important, of course. Then another option would be to offer multiple gender alternatives. This is something that Google Translate does. You may have seen it. Let's say in Spanish, if you give it an input, it may provide two outputs. That it identifies the ambiguity and it says, oh, this could be translated La Doctora or El Doctor. But this is only limited to setups where you have this option to provide multiple outputs. When I'm translating a book, I cannot provide the different alternatives. And also, this, as you can imagine, scales exponentially when you have multiple ambiguities. If I say the doctor and the nurse, this is 4 alternatives. The doctor, the nurse, and the it grows exponentially. It's 2 in the end. Another option that, to be honest, I haven't seen in any setup, but it's something that we had in some discussions, that the system could identify the ambiguity and ask for clarifications. Let's say in a chatbot, when I asked GPT to translate something, it could use option 2, offer the multiple alternatives, or just say, oh, what you gave me might have, multiple alternatives. What do you want me to do? Or I make this assumption, so this. But this is impractical, and it may make your life hard for a simple task. So we're left with option 4, which is basically assign a gender. And that's basically what most empty systems, at least the ones that we use, that the more general purpose empty systems do. Yeah, sorry for the example, it's in Greek, but you can trust me. The blue is the masculine, the reddish is feminine. So you can see that Google Translate translates occupations in a way that I think more or less we would all expect. Doctor, CEO, plumber are stereotypically masculine occupations, while nurse, secretary, or cleaner are stereotypically feminine. And this is reflected in the translation. So our contribution in this line is basically we introduce a framework to systematically evaluate gender bias in empty system when translating gender ambiguous occupational terms. And using our framework, we proceed and evaluate some empty systems in Greek and French, yes. And then we will see that we also try to use a reference distribution, let's say, to see, okay, we can quantify it in some way, but a percentage on its own might not mean much. So you may need to compare it to how does this compare to real distributions. Let's say, okay, we can see that the doctor is always masculine, but in the real world, doctors in many countries are almost equal, represented by men and women. On the other hand, you can see that the plumber is almost always translated into masculine, but also in the real world, in most cases, the plumber is indeed the man. So to be specific, we introduce a benchmarking data set with English text that contains gender ambiguous occupational terms. We propose a methodology on how to leverage that data set to detect and quantify occupations. We introduce a metric for that, and we evaluate some empty systems. So first, about creating the benchmarking data set. We want English text with gender ambiguous occupational terms. So what would be the source of our text? Where can we find such text? We consider some data sets that already exist that address occupations and gender biases. Yeah, we name a few. But these data sets only cover a very small percentage of all the occupations. I think in most cases, like 40 in one and 60 occupations in the other. And if I'm not mistaken, these datasets are created using some specific patterns. So we discarded these basically because of the coverage. We also evaluated with these datasets, but and also these in most cases have gender indications. We found very few examples with true gender ambiguity. Then we said, okay, we could maybe search some existing data sets that are widely used in machine translation, let's say the WMT dataset and C4, which is a curated version of Common Crawl. We chose this because one is widely used in MT, the other one is widely used in LLM pre-training. For that, we needed to see now how we can find text with occupational terms. We created a pipeline to automatically process text and detect occupations to see at least what we have. And after processing, I think 250,000, like 250,000 text, I think we identified again like 30, 40 occupations. So that was also not an option if we wanted a wide coverage. And then that left us with LLM generated texts. Of course, we manually inspected all the generated texts. It was an option that we wanted to avoid in most cases, but we didn't see another option when in order to have a full coverage. And then which occupations should we evaluate? We wanted, as I said, to have full coverage. And for that, we based our work on ISCO 8. So ISCO 8 is the International Standard Classification of Occupations. It's a classification system for occupations. It's endorsed by ILO, the National Labor Organization. And it provides a hierarchical structure that categorizes jobs into 4 levels of increasing granularity using a digit-based coding system. This means that we have professionals with code 2. This splits into science and engineering professionals and health professionals. This splits to medical doctors, nursing and midwifery professionals, etc. Of course, there are many classes there. And this hierarchy has 10 major groups, 43 submajor, 130 minor, and 436 unit groups, which these 436 are basically the occupations that we have in this work. So this led us to Gambit MT, the dataset that I mentioned, almost 10,000 texts, all with ambitious gender on occupational terms, covering all ISCO 8 occupations. It was generated using Claude. And to have some diversity on the text format, we used some different options when we prompted the LLMs, short stories, brief news reports, short statements, short conversations, and short presentations. And you can see an example here. So through the generation, we have the type, we have the ISCO code, and then we have the text, which we have an occupation mentioned. And if you read it through, I think you cannot deduce the gender of that occupation. So then let's say that we have this text that is an English text from our data set, and you have the translation. I think this one is in Spanish. Yeah. And how can we utilize this to detect actual gender biases? So first, we need to identify the occupations in the text. Then you need to identify the gender. And then if these do not match, if you have a gender asymmetry, this is an indication that there is a possible gender bias in this. So we wanted exactly a tool that can do this, detect occupations and provide the gender. And in the English text, we already had it because we created the dataset. So we wanted it in our target languages. For this, we just used an LLM with few shot prompting, more or less, with some refinements to eliminate some hallucinations. We did some embedding similarity with the ISCO 8 descriptions. But the main idea is that you just take an LLM and few shot prompt it, and it's pretty accurate on this task. And then there's the question that I mentioned. What can you use as a reference? We have the detection, let's say, we can quantify that 90% of in the text that plumber is translated into masculine, but we thought it would be interesting to have also a reference distribution to compare it. We have two, let's say, approaches in this. One is normative correctness, let's say, which evaluates the system behavior against an idealized standard of fairness. In this case, this could be gender parity. So we compare how the system outputs compares to an ideal, let's say, 50-50 distribution between masculine and feminine. The other approach is predictive accuracy. So we assess how well the system reflects a reference distribution. In this case, we use real-world gender statistics for each occupation. And this, I think, creates an interesting reference to see also when we're trying to seek for the source, let's say, of the bias in some cases. To quantify gender bias, we created, as I said, a metric. And the metric basically compares the output of the system to a reference distribution. And that you can do it for both genders, like for male and female, we have as a reference. The reference can be either 0.5 if you use normative correctness, or you can replace that with the percent of, let's say, of people working in a certain occupation, male or female in each case. So I don't know how I'm on time. Still have some 10 minutes, 5 minutes. I'll try to rush. So the results of our evaluation. Overall, as expected, we saw that empty systems overwhelmingly translated gender ambiguous text into masculine forms. This is something already known in literature. We have masculine as default. So in most cases, we see that the systems default to masculine. Here are the systems that we used to evaluate. We took some machine translation engines, and we also used some LLMs as translators. We used the prompt provided by the creators of each LLM. And another interesting observation is that this masculine as default is not always the case. But what is more frequent is that you always have an extreme gendering. So in most cases, let's say more than 85% of the cases, more than 80% of our text for each occupation will translate it to one gender, either masculine or feminine. In most cases, it was masculine. As we said, we have masculine as default. But there were some cases that we also had feminine translations, almost in all cases. So we can see that the systems, in many cases, like to associate certain occupations with certain genders. It's not only about defaulting to one gender in general, but it's about how you associate certain occupations. The second shows like the extreme gendering cases, and then some more mediocre, like some moderate cases. So you can see that it's almost in all cases extreme gendering. Now we thought about checking about the effect of gender stereotypes. So we took some research where it splits, let's say, occupations depending on how stereotypically masculine or feminine they put it in a scale from 1 to 7, and we took the most masculine, most feminine, and the middle we created, let's say, a neutral category. And we wanted to see the behavior of empty systems in these categories, let's say, that we created. And we can see that, as expected, into stereotypically masculine, they always default to masculine. In what is interesting, that is also in neutral cases, they usually default to masculine. But in the stereotypically feminine cases, it's a more mixed, as you can see. This is the last column, where you can see that in many cases, it's more towards feminine translations, or at least a more mediocre, let's say, approach. So we keep that stereotypically masculine and neutral are translated into masculine, while stereotypically feminine in most cases in feminine. Now about divergence from the real world. As we said, that we can see that empty systems do not simply reflect real world gender imbalances. They often amplify or even distort them. We saw many cases where occupations that are dominated, let's say, by women in the real world still defaulted to masculine. And this seems to reflect, let's say, the distribution of occupations that we had some decades ago. I think we found some statistics around the 1930s. And the distribution at that point was much closer to what we got from the empty systems compared to today's distribution. Something that we want to check is if we could get historical data and see, you know, our empty systems are closer to which year. I think it will be something around, 1930s, 20s, something like that. And We also check the correlation of empty outputs to real-world distributions and to the stereotypicalness scale that we had, let's say. And we saw that consistently, slightly, but consistently, the empty outputs were closer to stereotypes than real-world distributions. And while inspecting the real-world distributions of occupational data, we see that slowly the gap closes, let's say, in terms of participation. Of course, there are still big differences in other parts of the labor market, but in terms of participation, the gap closes. And so our systems diverge more and more from the real world, not because they get worse, but because real world progresses towards a more equal representation in some cases. And okay, this is the last part, just to mention that what the NNLB, the 1.3 billion model, seemed to be the less masculine as default. And in most cases, you can see that it diverges also in terms of alignment. This is basically the correlation between the models, and you can see that NNLB diverges from that. While in the other cases, most models pretty much aligned in their outputs. And the last part is about the alignment between the languages. You can see that almost all models, again, but NNLB 1.3 billion, they have more or less very much aligned into two languages. This seems that they have the same bias, let's say, in the same occupations. This could imply that they have a common representation of the occupation, or just that the biases are the same in the two languages. But from the NLB, we can see that this might be more close to how the distribution in the actual data is. And yes, okay, then closing with this, some challenges and limitations of this. Well, we know that the limitations, as I said, that our data set is artificially generated, and we treat gender as a binary feature, which we know that is not the case, or at least according to recent research. But the fact that we're using also grammatical forms, and the fact that all occupations, until the statistical agencies offer statistics only in males and females, we needed that binary, let's say, form of gender. And there are also some emerging professions, let's say, that are not already in ISO 08, so we may need to expand it a little bit. Okay. Another direction, which is like a side paper that we did, was to create a knowledge graph, trying to incorporate also statistics from data sets, because I think that other than comparing our systems to the real world, it's interesting to compare our systems, the real world, and the data sets, because all these three, they're not aligned, as we can imagine. We know about the representation in data. There are many representation issues in our data. Don't focus on the structure, a bit complex, I should remove it. But the idea is about also comparing our models with data and then with real worlds. These are the publications that I mentioned. The first one will be presented in Vienna in a couple of months, which is about the contextualization of harmful language in cultural heritage metadata. The second one is still under review. It's on archive, you can find it. And the knowledge graph was presented in a workshop of the Conference on Information and Knowledge Management. So I think I'll skip it. We know what we talked about. And the next steps is basically about regarding the derogatory terms detection. We want to contextualize explanations with an LLM, because for now we basically present the vocabulary entries as explanations, and we're also trying to detect and contextualize harmful language beyond the vocabulary. But as I said, this needs to have proper grounding, so we're still working on that. On the empty system evaluation, one line of work that we're currently working is about evaluate gender bias of machine translation quality estimation metrics. I know that some people here already have some work on that. And we want to also incorporate the gender ambiguous cases of into that evaluation. As I said, we want to quantify gender segregation in textual data sets. And an idea that actually Chris is not here now, but she proposed, was to also consider uncertainty into the evaluation. Because now we treat basically the empty system as a black box. We just see the outputs and we aggregate the outputs. It would be interesting to see if the model identifies the uncertainty, let's say the ambiguity, and that could be incorporated also in the evaluation framework. And some other discussions about extending beyond machine translation, as the same biases are exhibited in large vision language models, etc. these are some contributors that worked with me in these papers. And yeah, thank you. That's it. Sorry if it took longer.
Sure, please.
No, no.
Presentation.
My pleasure.
Maybe we have time for one question, if anyone.
And I'll be around if anyone has, we can chat afterwards.
Chat afterwards.
Yeah, if anyone needs to leave.
Okay. Thanks a lot, everyone.